This is SpaceTime Series 22, Episode 14. Coming up on SpaceTime, a new fundamental constant of the Sun. New images show Ultima Thule is more like a walnut pancake than a snowman. And how black hole mergers could be revealing new particles. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered that magnetic waves in the Sun's corona, its outermost layer of atmosphere, react to sound waves escaping from deep inside the Sun. The findings, reported in the journal Nature Astronomy, means the Sun's magnetic waves behave differently than previously thought. Scientists had thought that the waves originate at the Sun's surface, where boiling hydrogen at temperatures of 6,000 degrees churns the Sun's magnetic field. However, the new research shows evidence that the magnetic waves also react or are excited higher in the atmosphere by sound waves, that is, pressure waves, leaking out from deep inside the Sun. The sound waves were found to leave a distinctive marker on the magnetic waves. The presence of this marker means the Sun's entire corona is shaking in a collective manner in response to the sound waves. And all this is causing it to vibrate over a range of frequencies. This newly discovered marker was found throughout the corona, and it was consistently present during an entire 10 years of direct observations. The study's lead author, Dr. Richard Morton from Northumbria University, says these magnetic waves, known as alphenic waves, play a crucial role in transporting energy around the Sun and the solar system. He says these new findings are exciting because it suggests they represent a new fundamental constant of the Sun, and potentially a fundamental constant of other stars as well. The findings could therefore have significant implications for science's current ideas about how magnetic energy is transferred and used in stellar atmospheres. This newly discovered and very unique signature could lead to a new way to examine and classify the behavior of all stars. The Sun's corona is over 100 times hotter than its surface, and the energy streaming from the alphenic waves is believed responsible for heating the corona to temperatures of around 1,000,000 degrees. The alphenic waves are also responsible for heating and accelerating powerful solar wind from the Sun, which then travels throughout the solar system. These winds are travelling at around 1.6 million kilometres an hour. And they also affect the atmospheres of planets, impacting on their own magnetic fields and causing phenomena such as aurora. Morton says the new evidence shows the Sun's internal acoustic oscillations are playing a significant role in exciting the magnetic alphenic waves. He says this gives the waves different properties and suggests that they're more susceptible to instability, which could lead to hotter and faster solar winds. You're listening to SpaceTime. I'm Stuart Gary. New images of the distant Kuiper Belt world Ultima Thule show that it's far stranger than previously thought. The evocative new image sequence from NASA's New Horizons spacecraft offers a departing view of the distant frozen world, which was the target of its New Year's Day flyby. These aren't the last Ultima Thule images which New Horizons will send back to Earth. In fact, many more are to come. But they are the final views New Horizons captured of Ultima Thule, officially named 2014 MU69, as it raced away from the frozen world at over 50,000 kilometers per hour, back on January the 1st. Now, you may recall those first close-up images of Ultima Thule, with its two distinct and apparently spherical segments, had scientists referring to it as a snowman. However, more analysis of both the approach images and the new departure images have changed scientists' view, in part revealing an outline of the portion of this distant world that was not illuminated by the Sun, but could still be traced out as it blocked the view to background stars. Stringing 14 of these images into a short departure movie, New Horizons scientists found the two segments or lobes of Ultima Thule aren't spherical. It seems the larger lobe, nicknamed Ultima, more closely resembles a giant pancake, while the smaller lobe, nicknamed Thule, is shaped much more like a, sort of dented walnut, really. Mission Principal Investigator Alan Stern from the Southwest Research Institute in Boulder, Colorado, says nothing quite like this has ever been captured in imagery before. Scientists had an impression of Ultima Thule simply based on a limited number of images returned in the days around the flyby. But seeing more data has now significantly changed scientists' view. Stern says it would be closer to reality to describe Ultima Thule's shape as flatter like a pancake. But more importantly, the new images are creating scientific puzzles about just how such an object could even be formed. Stern says astronomers have never seen anything quite like this orbiting the Sun. The images were taken nearly 10 minutes after New Horizons crossed its closest approach point. The departure images were taken from a different angle compared to the approach images, and so reveal complementary information about Ultima Thule's shape. The central frame in the sequence was taken when New Horizons was already 8,862 kilometres beyond Ultima Thule and more than 6.6 billion kilometres from Earth. The object's illuminated crescent is blurred in the individual frames. That's because a relatively long exposure time was used during the rapid scan to boost the camera's signal level. But the science team then combined the processed images to remove the blurring and sharpen the thin crescent. Many background stars were also seen in the individual images. Watching which stars blinked out as the object passed in front of them then allowed scientists to outline the shape of both lobes, which could then be compared to a model assembled from analysing pre-flight images and ground-based telescope observations. New Horizons was launched back on January the 19th, 2006, from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket. The probe made history on July the 4th, 2015, when it became the first spacecraft to visit Pluto, flying just 12,500 kilometres above the 2,377 kilometre wide dwarf planet's surface. New Horizons also visited Pluto's binary partner Charon and their 4 moons, Styx, Nix, Kerberos and Hydra. Pluto is one of the largest known bodies in the Kuiper Belt, a ring of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune. New Horizons' next encounter was on January the 1st, 2019, when it undertook its close flyby of the 30-kilometre wide Kuiper Belt object 2014 MU-69 Ultima Thule. By the way, that name, Ultima Thule, well, it's an ancient traditional name used to describe the most distant place known, a land beyond the borders of the known world. In ancient Greek and Roman times, Ultima Thule was the place furthest north, now thought to refer to Iceland or Greenland, although both the Orkney and Shetland Islands have also been referred to as Ultima Thule in medieval times. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Okay, Fred, it's like visiting an old friend. We keep going back to the New Horizons probe and the data it's sending back, not only the stuff from Pluto, but on New Year's Day, one of the great achievements in, I suppose, astronomical investigation or exploration was the passing by of the object known as Ultima Thule. And the latest image is coming back, bearing in mind this data is going to keep coming back over the next 20 months or so. So there'll be more new images to see, I imagine.
That's right. In fact, there's apparently another one on its way. The reason why we're talking about this yet again, and we've certainly given it quite a lot of prominence in the last few weeks, Ultima Thule is revealing its secrets. We're seeing steadily higher resolution images. And the new one that has just been received, and of course it takes a matter of time because of the very low bandwidth of the signals coming back from the New Horizons spacecraft at 6.5 billion kilometres away.
That's because they're using the Australian NBN service.
No doubt that is the case, yes. It's now seen at a resolution which is quite fine, actually, considering what we're looking at, 135 metres per pixel. But that comes from a wide-angle camera on board New Horizons. And we know that the same image that we're looking at, you and I are looking at, maybe our listeners are too, the same image is also in the memory banks of New Horizons, taken at a much higher resolution by something called the Long Range Reconnaissance Imager, otherwise known as LORRI, but that has not yet been down-fed to the stations so we can see it. However, we're getting some very, very enticing information from this wide-angle view that we've got of Ultima Thule. It's about 33 kilometres from one end to the other. It's 2 blobs stuck together, one now called Ultima, the other Thule. If I remember rightly, the big one's Ultima. And you can already see evidence of cratering on this body. Some very peculiar looking features. The smaller part of the object seems to have a huge crater in its side with
looks like it's been hit hard by something big.
Exactly, that's right. And no doubt there are others all over because that's how these things, how they come together by things crashing into them. And you can see a number of smaller craters or pits. It's not clear what they are. They could be the result of outgassing, activity within the object itself, where gases are coming out for some reason or another, or they could be small impact craters. My guess is, looking at them with my expert eye, my guess is that it's the latter, that they are probably smaller impact craters. But it is just a fantastic thing to see. This is basically a monochrome image that we're looking at, although there is colour available on that camera. We know it's already that it's a sort of pinkish red colour. Lots of bright streaks on it, which also suggests that there is activity of some kind, or has been, on the surface, because bright stuff on an object like this is usually the more recent stuff, powder that's been deposited on the surface. Remember,
you can certainly see that at the join where they've come together.
Indeed, that's right, yeah. It is going to be lightish in colour. And as you said, the neck region is much brighter. And the suggestion there is that is powdery stuff that's fallen into the crack between these two objects that when they came together, so that they don't join as such, they are just in contact.
So what keeps them together, Fred, and could they be torn apart? Gravity.
Yeah, it's a great look. That's a great question, which leads into something I was just about to say. Because one of my colleagues in Canberra did a quick calculation when we saw the first images of what the pressure might be between them, given the fact that we've got these two objects which both have not very much gravity, but enough to hold them together. And the pressure is high. It's in the region of tons per square inch. Just depends on how much contact area there is between them. He was assuming, he just took a wild guess as to what the contact area is between them. Of course, if it's all at one point, then it's a very high number. If they've kind of flattened out a bit so that these two things have squashed together slightly, then the pressure holding them together is much less.
It's like surface tension, I suppose.
It almost, yeah. That's right. And, there may be effects of that kind that help to... It's basically gravity that's doing the job, but there could be interesting surface effects going on at the neck region. Yeah. The great thing is we're going to see far more over the next few weeks. You and I will be hard-pressed not to talk about it on Space Nuts, so I apologise in advance to you. Who might have heard enough about it already. You're going to get more.
Well, you just never know what the next image is going to reveal, and it might be something incredible that we've never seen before. So that's the reason to do these missions, and to find as much as we can, download as much data as we can. And with the technology that's available, we can do some amazing things now. And as we mentioned last time we talked about this, they've got their eye on another object, so they're going to do a second flyby. So it'll be interesting to compare notes, really.
That's right. We await further news on that. The NASA mission scientists, Alan Stern, the principal scientist, will be, I'm sure, musing over what kind of trajectory adjustment they can make to bring another Kuiper Belt object, these distant objects are called, into the range of New Horizons.
That's Dr. Fred Watson speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. A new study suggests gravitational wave signals could contain signatures of extremely low mass particles that might be a component of dark matter. The hypothesis is published on the Pre-Press Physics website archive.org. Dark matter is a mysterious invisible substance which makes up about 75% of all the matter in the universe. Just a quarter of what we see is made up of normal baryonic matter, the stuff that makes stars and planets and houses and dogs, cats and people. Even though we can't see it, we know dark matter is real because we can see its gravitational influence on normal matter. Right now, the best bet for what dark matter is some kind of new exotic subatomic particle. Dark matter searchers mostly hunt for relatively massive particles. However, some theories predict the existence of extremely lightweight particles could explain dark matter. Particles not occurring in the standard model of particle physics. One candidate is the hypothetical faster-than-light particle called the axion. If they exist, these very light mass particles wouldn't show up in particle collider experiments or in dark matter searches. New calculations suggest that axions may be ultralight bosons, and they could be detectable in gravitational wave signals from merging black holes. In fact, clouds of these ultralight particles could be created by fast-spinning black holes. And when two black holes collide or merge, the cloud would undergo a rapid collapse, and that would affect the harmonics of the gravitational wave signal from the black hole merger. Therefore, gravitational waves could thus provide a novel new way of detecting particles inaccessible through ordinary experiments. Something new for the physicists at LIGO to start looking for. I'm Stuart Gary. You're listening to SpaceTime. And time now to take another look at some of the other stories making news in science this week with a science report. NASA has discovered a giant cavity, 2/3 the area of Manhattan and almost 300 metres tall, growing at the bottom of the disintegrating Thwaites Glacier in Antarctica. NASA says the findings, reported in the journal Science Advances, highlights the need for detailed observations of Antarctic glaciers in calculating how fast global sea levels will rise in response to climate change. Scientists expected to find some gaps between ice and bedrock at Thwaites' bottom, where ocean water can flow in, melting the glacier from underneath. However, they were shocked by the size and explosive growth rate of the newly found hole, which is big enough to have contained 14 billion tonnes of ice, most of which melted over just the past 3 years. The cavity was revealed by ice-penetrating radar in NASA's airborne Operation Icebridge campaign, which has been studying the connections between polar regions and global climate since 2010. The research team also used data from Italian and German spaceborne synthetic aperture radars. So, did you skip breakfast this morning, or do you consider it the most important meal of the day? Well, a new report from the British Medical Journal claims that when it comes to weight loss, breakfast skippers might be onto something. They examined a host of studies that looked at the effect regular breakfast consumption had on weight change and energy intake. Overall, while the quality of evidence wasn't that high, based on the evidence they saw, those who skipped breakfast consumed less calories and were on average 0.44 kilograms lighter. The researchers say the idea that breakfast is the most important meal of the day comes from observational studies that could be skewed. Experts with the United States Naval War College and the University of Tel Aviv have discovered that internet traffic heading to Australia from Europe and North America was mysteriously diverted to mainland China over a 6-day period in 2017. The diversion, which could have enabled a major data theft, is being described by China's state-owned telecom as nothing more than a routing error. However, the experts at Tel Aviv University say they detected unusual and systematic hijacking patterns. And that suggests that, contrary to what Beijing are claiming, it wasn't an accident. The targeting of data bound for Australia follows recent revelations that China's Peak Security Agency is responsible for a surge in cyber attacks on Australian companies over the past year. And that's a clear breach of bilateral agreements not to steal each other's commercial secrets. A new study warns that teenagers who don't get enough sleep are more likely to take part in dangerous behaviours like smoking, consuming alcohol, taking drugs, having unprotected sex, driving dangerously, and committing acts of violence. The findings, reported in the journal Sleep Medicine Reviews, looked at data on over 570,000 teenagers who took part in 24 previous sleep-related studies around the world. The study reviewed the association between sleep duration and risk-taking, finding a direct link between risk-taking behaviours and falling short of recommended sleeping hours. Adolescents need between 8 and 10 hours sleep per night. They say there's money in trash and that there's a sucker born every minute, and that's certainly true for the business of fortune-telling and psychics. The immortal words of the character of Dr. Sheldon Cooper from the hit comedy series The Big Bang Theory probably says it best.
I don't mean to be rude or discourteous, but before we begin, I'd just like to say that there's absolutely no scientific evidence to support clairvoyance of any kind. Which means, and again, no insult intended, but you're a fraud. Your profession is a swindle, and your livelihood is dependent on the gullibility of stupid people.
The brilliance of the Sheldonian view on the universe. Still, fortune-telling is now a $2 billion industry in the United States. And apart from the occasional conviction for grand larceny, it's growing by around 2% per year. Joining us now to talk about this is Tim Mendham from Australian Skeptics.
It's actually been growing quite steadily for a number of years, but the rate of increase has actually gone up and down. The story often is that in hard times, people might turn to psychics to get some sort of comfort. In reality, it looks like in affluent times, people are just as likely to turn to psychics, whether they do it as entertainment or whether they seriously believe, hopefully not, the information they're getting is, I suppose you have to look at each individual case. But the growth evident in America of people taking up psychic information services has been growing every year. There's a survey done by IBIS World who regularly assess different industries, sort of genuine industries and this sort of stuff. And they said that that the industry grew by about 2%, revenue $2 billion in 2018. In the same time frame, the number of businesses has grown by close to 2%, and the number of employees has grown by slightly less. I mean, most psychic businesses have one employee who's the person who does it, the psychic, if you like. But I mean, the growth in previous years was a lot higher. 2014, it was about sort of 5% growth, 6% growth.
You're not going to tell me it's dropped because of unforeseen circumstances, are you?
I won't tell you that. But I mean, I don't know if it's actually shown. I mean, sort of the trouble is with these IBIS World reports, you have to pay thousands of dollars to see what the future predictions. But I mean, they're suggesting that it's going to continue to grow. It certainly hasn't shown a negative growth for a number of years.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.